So we make software for travel agents, travel professionals. They build itineraries like for a trip on our system. They add like supplier stuff. They can create their custom libraries. It's used by a lot of different people in a lot of different ways, but it's all centered around travel. So it started as like, hey, we're going on a bachelorette party. We don't know where to go and how we're going to get there, and we need to coordinate this planning. And we had our consumer tool, and then we got a ton of consumer users, but we're like, if we just get $1 from everybody, we can like retire. If you ever tried to get $1 from random people on the internet, it's hard. So our sales people was like, hey, people will pay for this. Like, it's free, they're not going to pay for it. And he's like, no, they'll pay for it if you can just slap their logo on there. And that kind of changed everything. Like that literally just completely changed from the company probably not being here to give this presentation to we're able to do this and still growing. So let's see what else we got. There's different ways that people can access their itinerary. This is important for later, it's not a sales pitch. They can get it from the web, where they just send their clients a link. They can send, everybody loves to send their client a PDF or like a Word doc. So they do that, or they print it out from the PDF. We also have mobile apps that people can get their itineraries. And some of those are like branded and stuff like that. That can be talking to itself. We also have an API where people can push, it's like a public API where people can push their itinerary details in. So if I hooked up, Travelco's system and got all the authentication going, I can say, hey, import this reservation, or they could automatically push it in and just save me time. Our things are, we want to save people time. We want to impress their clients, which honestly is like, make it look like it's from 2012 or later. Because most of these travel agencies don't have another way to do it. Like they don't host WordPress, they don't, like a Wix page isn't customizable enough for what they need. So we just need to make them look professional. And the other one is, what's the third one? Doesn't matter. And then we also have, this is also relevant, we have like white labeling for a web platform and the mobile apps, like I said. And it's really what people like is like the domain masking and the branding. People have done white labels know a lot more than I do, but people will pay for it to say trips.travelco.com, our fake white label place. And they want that to be in their brand. It's the same platform, it's the same thing, but we have to handle that, which presents an interesting challenge on the SSL, because we would never post that without SSL. Not that we take like super personal information, but like this is your trip and it's SSL. So, and then I stole the whole presentation part from him, so I had to put his contact info on there. So that's kind of an overview of Travefy. So today, particularly within the architecture stuff, I'm going to talk about like running our system for multiple APIs. And like, I'm in no way an architecture, I can't even say the word, architecture expert. We just get stuff that works and try and make it better. I actually didn't start at Travefy. Chris and Matt and a couple other people can take credit for all the good architecture that I just built on, and I am more apt to present on it. So all the good credit goes to them, all the bad credit we'll share as a team. But it's kind of interesting because we don't. We grew from a pretty small like skeleton team that had to like ship features like crazy to where now we're part of these agents use our stuff for hours a day, and like we can't be down, we can't break stuff, we can't move their cheese a lot, and we've also built a lot of like ancillary parts to that. I mean it's no different than any other software story, but we kind of have a little bit of a different way of just running. Kind of separating out things and almost running like multiple APIs, and I'll use that term for both internal and external, on a single system. And this is just the way that works pretty well for us. It's not like, it's just a view in. So if you have questions, just yell or raise your hand, I might ask you. Then I'm going to talk about our unique answer to the SSL thing. And then I'm going to talk a little bit more about our API, just because I think it's pretty cool. Maybe because that was mainly what I did. So this is a Travefy party, kind of looks like an Amazon dash button. It's my one animation in the whole thing. So We have basically like the source of truth is like our DB and our cache. And we have like, I don't know, I'm gonna just yell out a bunch of stuff that we use just so people kind of know, but I don't care what people use. Like we use MS SQL, it's all hosted in AWS, we use Dynamo, we use, I don't know, just like all the normal stuff. But outside that, we have repositories, which is kind of like our data layer. So they're not particularly smart, but they know how to interact with the database. We switch it from Dynamo to, I don't know, Redis or something like that. It's fine. And then on top of that, we have our services, which is like our business logic and stuff like that. And then those are shared essentially between multiple clients. And so I'll just run you through, and if it's not interesting, tell me, but just like our web client is like what you see in the web browser. You do your building of the itineraries and also presenting them. The queue, we just have like a background queue that does like email sending, basically anything asynchronous that, or like if webhooks come in, we like slap them on a queue and they get processed. We have a processor that we added. I don't know if it's like even a good word for it, but just like to do background jobs that we can like fire and forget it later. How's that different from a queue is a good question, but it is. Mainly because that one is using Hangfire, which is a really cool like background processing thing. We have our public API. Like I said, you can build your trips, manage your users, stuff like that. And then we have our mobile API, which only we consume, essentially. And all of our different mobile apps consume that. And it's like these three things are all hosted like even in the same like web project, but they have separate APIs, right? So we don't necessarily have like a separate project for each of these, but they're all very separate at the API level. Like they are very conceptually separate, and they don't like a mobile app is not allowed to call this API, and we have to enforce that, but we enforce that. And then there's like a hub and SignalR, but that thing's awesome because it doesn't need to know anything about our like our data levels and stuff like that. So that's kind of like how stuff's set up. Again, some of this is like just how it was presented to us. We obviously have like tests that test the services, we have tests that test the repository, we have tests that test the API, and different tests do different things like that. So just real quick, I wanted to talk about some of the kind of design trade-offs and considerations in that. So like obviously like less duplicate code, you know, everything, if you're doing a crazy itinerary operation, put that in a service, like you put that in a controller and that's gonna come crack your skull. It separates out the concerns of things, so like when like a mobile app can only do this or can't do that, it's very much apparent that it can or can't do that versus the web app and stuff like that. And then also versioning, like our mobile app development is pretty sporadic. Actually, and like everything is kind of like, okay, we got 3 weeks on this and then 2 weeks on that, because we've got a lot of irons in the fire. So being able to just say like, okay, I know this isn't gonna break anything, and if I do, I can like version it up and nobody else will be impacted. So those are all good things. Some of the cons, in my opinion, I don't know, Chris can chime in if he has others, but we have like lots of mappings because we don't like pass a single. If you're at this, you know all these things, but you don't pass like a single data type all the way through. You know, like because things change, and so luckily we get away with that with like AutoMapper. There's a bunch of other good mapping things that'll map like properties. So your database object and then your data layer object, there's mapping between there, data layer, and your services, there's mapping, and so on.
Do you encapsulate your queue calls similarly to like a database call, or how do you handle normalization of getting things out of those asynchronous sources?
Sure, just rephrase that maybe.
So I noticed that you had queues as one of your resources.
Yep.
Can you call in or get an event from that queue from anywhere, or do you have some way in which that is?
Yeah, we have a service that like, yeah, so basically like, can I put stuff on the queue from somewhere else? Or is that kind of it? Like how does the queue get stuff on and off of it?
Yeah, so do you just like call the Microsoft or I don't know if you're using it right. Do you just use the library wrapper for the queue just anywhere in code, wherever it needs it? Or do you have like a accessor?
Yeah,
Okay.
so we have like a repository thing that handles the queue. So you're like, hey, throw this message on this queue. Somebody else is going to pick it up. It might be in a different one of those projects or anything like that. And then the same way out, like our processor is like, hey, pull this queue and see if there's any messages. Is that kind of?
Yeah.
what you're asking? Yeah. So we don't like, the queue is treated as another resource. I think is kind of where you're getting at too. It's not like a utility where anybody can get to it from anywhere. It's more like a resource.
It's a resource, not a service.
Yep. Yep. So again, we just have lots of mappings. It can create some like interesting headaches and stuff, but it's not too bad. Like it'll save you more than it'll hurt. And then just like being aware of your dependencies. If you do have everything in the service, and you do have a lot of things accessing that service, and you don't have perfect testing, which is probably everyone, you can easily break stuff without even knowing that you broke it. So you just have to know, which is not good. Like you just have to know is probably a smell. But you just have to kind of be careful on stuff that's commonly used that you're not making huge changes. So some of these are like growing pains we're still going through. So yeah, like I said, that was kind of our like overview of our architecture. I was gonna just see if there's any other questions on that. Yeah.
I'm gonna go back to the queue service. It's something I've been thinking about recently.
Okay.
So part of the queue is receiving events, push notifications about events. How do you handle getting those real-time events from a repository? Or how do you subscribe to events from the queue if it's a repository?
Oh yeah. So I think I'm gonna say this right. Our services just pull that repository. So we have a service that's just pulling constantly.
Okay.
For the most part. We don't, in particular for a queue, we don't have like push things. We just have like a pull that's eager, and as soon as it gets something, it just goes. So
Okay.
we use SQS if anybody cares. Just Amazon's queuing service. Yep.
Thank you.
So the next one is our fun challenge of SSL. But again, it's worth your time. All these things are true, and you should do SSL. And that's all I have to say about that. So we have kind of a unique. It's obviously not super unique, but it was unique to me. Well, our SSL situation, right? So we have like 50 or more domains that we all have SSLs for. Just before you ask, we didn't use Let's Encrypt until very recently. It wasn't, I don't know, we just didn't, and now we're gonna because that's a lot of money too. But we use AWS. AWS is, yeah.
So I was curious, and since you're talking about Let's Encrypt, I've always wondered about that. Is there like a quality difference between that one versus the ones you paid tons of money for?
Nope.
Is it all the same security? It's just
Yep.
based on how to do the free where everyone
Yep,
else
they're
uses
all,
it.
as far as I know, they're all like, it's trusted just as much as anybody else.
Okay.
Yeah. And it's pretty easy, so it's pretty easy for running like a single website. There's just like, do this plugin, and this PowerShell script, or this like Python thing on Unix, and like, it just works.
Okay.
But it's not great for us for like 50 domains. because it's like, yeah, we blow away your Nginx config, and then like, here you go. But it's awesome, and it's free, and it's easy to set up on the normal case. So, the only caveat is like you have to renew it every 60 days. 90 days is when it expires, but you have to renew it every 60 days. But the renewal's pretty easy. Like, they'll just say like, hey, challenge, do you have this file on your domain? Yep, here it is, and then here's your new server. So, most of those plugins handle it for you, which is nice to know. So we run AWS, and if you use their Elastic Load Balancers, they have like an SSL termination there. And you get to choose where to do this, right? Like we could put them all on IIS, but like we have we have a couple web servers, and we could have tens of web servers. And you don't want to like manage all the IIS certificates. You could. We didn't want to manage all the IIS SSL certificates in IIS. And Amazon did an awesome job at the load balancer level but they have limits. And we can go above that limit, but like it's kind of a hassle to manage that. Another question again is like where do you terminate that, which is important, and then how do you handle like renewals and adding and removing certificates and stuff like that. So this is like our good enough solution. It definitely is a little janky, but it works just fine. I'll talk a little bit about some of the good and bad. You can probably see the bad, but I'll just kind of explain how a web request comes in and hits Travefy, how it hits their servers. So it comes through, it's our external load balancer. I took those duplicates out because it's for clarity. And that passes straight through on our load balancers. They have the option to not terminate SSL and also like just accept just like any TCP and pass it straight through. You can't necessarily do like a listener on that because it won't work with the SSL. It's just like an ELB thing. But basically it just passes the request straight through. So you're wondering like why? It's because at the next level is our Nginx boxes. And these are the things that terminate the SSL. So this is the thing that has a certificate. This is the thing that when a request comes through, it's like, hey, I'm legit, here's my certificate and stuff like that. And so the reason, and it's really pretty simple, like if you've seen Nginx, it's not crazy. You don't need, this is just like, it's Nginx, it's code. So the reason we have this ELB here is because we have multiple Nginx boxes. They're running on like, kid you not, like $5 a month Linux boxes, like micros, because they don't have to work that hard. But we want multiple of them because they just like randomly lock out because they're $5 a month. And so this allows us to, when you do maintenance on one of them or two of them, or one of them pops out, that ELB can handle. Like I can go to sleep and wake up and be like, oh, the Nginx box was out for 10 minutes. ELB was like, I got this. I'll send you an alarm and wake you up. But it knows, hey, this Nginx box is out. Let's not send stuff to it. So again, like you just have a listener basically for each domain. And so because of this Nginx box can take requests for all those domain names and handle this SSL termination for all that. And SSL termination isn't free. So that's like, but it's really, Nginx is very good at it for the traffic we see. So then the Nginx boxes, again, why? But they point to another internal load balancer in AWS. And this one takes, don't worry about the 81, we have like a sandbox for it. But they just take HTTP and HTTP because the Nginx box has unwrapped the SSL around the request and is just passing the plain request straight through. Obviously, disclaimer, if you're doing like PCI or HIPAA stuff, like don't take any of this because I don't know what your requirements are. But essentially, from here on, that request is coming in plain HTTP, which is cool because it makes things easier on the IIS. So then at this end, IIS is just running, like I said, a sandbox in a production website. It's just listening on 80. And we have the reason for this load balancer is because we have multiple web boxes. So rather than our Nginx boxes, all of our Nginx boxes having to keep track of which web boxes are in rotation, how to deploy to them, blah, blah, blah. Nginx, they always just point to this thing. And this thing is always up because of it can go down, but like ELB is down, the internet's down. And then they can handle, the rotation deployment and stuff like that. And so that's kind of like it in a nutshell. And I'll talk to you about some of the pros and cons. And then another pro I didn't put on here. So the number one pro is it works. So it's pretty simple to manage. And I would put in there like, not only from like managing the components of it, from like, I can work on an Nginx box and not worry about it. I can completely add 20 web boxes and not worry about it. It also makes the security pretty easy to manage because the security groups on all those, every single slot there are very locked down. Like Like, this is the only thing that can receive stuff from the public at all. It can only come in on these 2 ports. This can only receive stuff from here, and it can only come on these 2 ports. This can only receive stuff from here on 1 port, and so on. So like, that was a nice thing, just because like we don't want people to hack our stuff. So that's kind of what I mean by like the management. And then we're using like off-the-shelf stuff, which is great because if you're writing a load balancer, good for you. So cons, just the fact that there's 5 steps in there. I don't care if they're all in Amazon's data center. There is added latency to this. Like, luckily this isn't like deal breaker for us, but it's not negligible. Like, it does have to go from here to here to here to here. And then there's also some multiple points of failure versus, I guess our thing before this is we have 1 ELB and then our web box is behind that. So like the levels of failure there are more, but we do that by mitigating everything. We have at least 2 of everything running all the time. If we only have 1, we get another con though is it's kind of a weird setup. So just like, I don't know, you have to putty in for some stuff. You have to do some stuff from the Amazon console or command line. You have to do some stuff in IS. So it's a bit of like a mashup, but who doesn't like using putty stuff? So yeah, that is hopefully interesting. Are there any questions on that stuff? Spencer, keep coming. They're not easy to see.
So what is the advantage of terminating the SSL at NG or Nginx versus having each web box with its own SSL server?
Yep. So it's whichever you want to do. Our main thing was we found that the SSL certificate management itself is easier for us to do in Nginx than this. Nginx, I could just run 1 command and then like pops in the SSLs. But not to say you couldn't do that in IIS, but I don't know. We just chose to do it there. I don't think there's like a performance. We didn't make that choice on performance. It was just like the easiest way we saw it to.
It's kind of opaque in IIS.
What's that?
Managing, automatically managing SSL in IIS is a little bit opaque.
Yeah.
Also simplifies deployment. It simplifies deployment, terminating there so that your deployment's not integrated with your SSL.
Yeah, true. That's another thing. Is like our IIS bindings are really dumb. Like, it's just listen on 80, and they're not hooked to any certificates or anything. So like, if we add a certificate, we don't touch the web box. And if we do a deployment, we don't touch the certificate box. So yeah, that's a good point too. And then again, that's unique to our situation of adding new domains every week. I mean, like, I'm sure Flywheel could talk for several hours on this stuff, but that kind of works for us. So. And also doing several deploys a day. So if we only deploy it once a week, then probably need to restore it. Good question. Anything else on that? We'll get to the GC API stuff. So last thing I want to talk about quick was just our API. We were lucky enough to have like a pretty robust product, like core product, a very willing and helpful partner to help us develop this, as in like they were consuming it. And so we got to just test stuff with them as we were going. And so we'd be like, hey, we're thinking about doing it this way. Why don't you give it a couple calls to see how it goes? And so we kind of got like a pretty fortunate way to develop that. So I'm going to talk a little bit more about the testing and the documentation. So you can see our public documentation here. And then the running theme through this is we love Postman, and you should too. Not only because we're featured on their website, we're kind of one of their early guinea pigs on some of their like data stuff, like public documentation, and it has worked out very well for us. So I guess like development-wise, it's just the same as we were talking before, as far as it's on top of our existing services and stuff like that. Data models were slightly different. Obviously, there's like some internal stuff that we don't want to show. There's we store like external IDs on our stuff. So we have like a Travefy ID. We but you also have your own ID, and you can like look them up by age and stuff. But the fun stuff that we do is testing and kind of how we develop on here. And I'm gonna, so like when we're doing API stuff, we're just like living in Postman. Is that showing up? Okay. So we have like, I use Postman for everything. Like I literally have, if I'm like playing with an API and I'm like, you know, I wanted to see how, you know, TypeKit does these requests. If I ever get them, I just save them because you never know when you need them. Or if I'm like, I want to do, for doing integrations with people and stuff like that too, just like I always have these things open. So we have an internal and an external collection are kind of our mainstays. Our internal one we use for our continuous integration testing. Team City just runs this whole collection in a command line script and integrates with that. And then we use it for development too. And so for instance, like let's say...
Can you turn those front lights off, mate?
I'm not sure I can. Might be one of, yeah, like Andy will work on it.
This is gonna have to be.
Give it about 10 minutes.
Yeah.
They was trying to obfuscate the code.
Yeah, this is our security measure. Basically we have a couple things that are kind of weird, like an environment selection one, because you can point to like your local host or like your stage or like our sandbox. And the way we really use Postman, and they've gotten, don't take this as like canon because there are better ways to do this. We basically have an environment and we set these environment variables to be used. So like that tells us like what, for example, what URL to use, what authentication stuff to use. You'll see later we store information about this. So this script runs before this request. This is just a dummy request. And so when it runs, all of a sudden, like you're set up to have this environment of your keys are all set. And so then on like these other requests, and this one's really hard to see, but there's this just a placeholder for your environment variables, and then it'll be that magically. So like default, ours goes to our staging server because that's how our continuous integration works. But it's super handy because, for instance, when I'm debugging stuff on one of our clients to see, I just have a script that I can run that says like set up tour plan, one of our clients like, or tour editor, their environment. So I get their like access keys and I get everything like that. So that's handy. But let's say we want to do something interesting and we're creating a user. So yeah, if you haven't seen Postman, again, I'm gonna sound like a fanboy because I'm a fanboy. We have like our authentication headers in here. In our body, we just have like a, you know, you can put whatever you want JSON files, you can, but you can't really automate as well. You can do stuff like little placeholders of like a timestamp or random number or something like that. And then what we use pretty extensively is the tests. So you can test things about the response. So is it a 201 created code? Does it say created? You can do pretty much any JavaScript you want here. And so what we do is just like, and some of these tests are more useful than others, but we'll just test that whatever we're doing was like reflected by the API. So for instance, let's say, and now we have a base. Anytime we add something, let's say that we're going to add like a user's favorite color field. So like you have a favorite color field, you pass it in. I'm going to add a test right now for like the user's favorite color should be blue when it comes back. And so that's super handy, especially having it in place because anytime again we see a bug or we add a new feature, we can just add one. And then you can also, again, magic environment, you can set these things based on the response. So now that I've created a user, I'm now making requests on behalf of this user, which is cool. So you kind of notice a pattern on, I'm not going to run some of these because they're ginormous, but you can notice kind of a pattern where we have like happy paths. So like happy paths, weird one. This is like actually our, some of our, again, this is all testing our public API, but just from the, but this is actually testing like our authorization and stuff and our permissions because we have like a collaborator role and they should be able to get stuff sometimes and sometimes not. So we're able to actually test those and then we basically just like fire a bunch of junk at them And I wish there's probably a better way to automate this, like basically like testing with like one key, like a public key right, and a private key wrong, and vice versa, and all the different combinations, or just like garbage data. But it's super handy because those go so fast because they just fail, and it just like expects an empty response unless our staging server is broken or there's not good internet, which may be true down here. But anyways, it's pretty awesome because yep, it worked. It just took 10 seconds. It's pretty awesome because like these will just chain one after another and just go, 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 go. So like you can build up your tests as you run. And I'll just run it. I'll just show you what it looks like to run the whole collection real quick. And you can, other things you can do is like you can put notes and stuff on here, which is really cool. Let's see if this works. So you can set like a delay or whatever, and all this good stuff. I don't know if this will actually pass. But basically your CI server, like our build server, does this every build. So this collection stays in sync. Yes, already failure straight. And then it'll just run this every build. So like, again, where our architecture is fortunately unfortunate enough that like Chris could be doing something in the web services stuff and that I can depend on the service and he could break it, at least he's gonna know before it like gets out to the public. So that's super handy. Like the next thing I was going to show is the documentation. Is there any questions on like the testing side of Postman? Yeah.
So you said it integrates with TeamCity. Is there a way to continuously, or to run those tests locally integrated with the build? Or?
There are, yeah. It's just a command line.
Oh.
There's a command line runner. Would probably be your best bet. So you could like write a package around that in JavaScript and run it. It's literally just one line, and then we have a reporter that like spits out to TeamCity, but it can spit out to a bunch of different types of stuff. And then they also, for like your public or staging, they also have, I think that they do a lot of crazy API support stuff. And one of the things is like they will continuously test against something public. Like they'll do the testing for you, and you can set it on whatever state you want. And they'll also do performance testing too. That's another thing I was going to mention, and it might be the reason that some of these are failing. But you can actually do other things around the stuff like we find one that usually fails. So like this is our mobile API. We have a whole separate test harness for that because it's a whole separate API. And like don't look at that. Pretend like that says 20 lessons. We have too many trips on this testing account. But you can check for the response time, again, like the code and stuff like that. And the new stuff in Postman, you can like tell it which request to go to next based on your outcome. So you can say like, if it was successful, go to this request, and then it'll like finish your test. So you can actually like change stuff up. Just haven't got there yet. But yeah, so Postman is awesome, if I didn't mention, and all this is synced like within our team. And I think they probably raised prices because we're like grandfathered in from 3 years ago, but it's like $5 a seat a month. So for us, it's totally worth it, especially because it allows us to do this, which is our public version. And we let us like, it does not have, you have to enter your own keys in there, like we're not going to give you our keys. But this is a fully like contained all the happy paths that you can hit in our API. So everything you can do in our API is here, it's documented. If you just fill your keys correctly, it will just work and run. And not only that, but we're nice enough to give you descriptions about everything in Markdown, and then it may be kind of wonky. Let me go to the branded, oh my gosh, branded version. So this is our public API based on our Postman collection, which is awesome. Like, it looks so fancy. And like, we show this to like our clients that we're looking to integrate with, and they're like, your API looks awesome. And I'm like, I guarantee they didn't look at any of the calls. They're just like, look at that. It says .travefy.com. It's got a block thingy. It's got their logo. It's great. But then the developer comes in and they're like, oh, our executive signed us up for a crappy API. I can't wait for this to suck. And they're like, wait a minute. I use, what's everybody's favorite language, Go, I guess. How do I get started with this request to go? Oh, there's the request right there. And there, Go must have cracks on the decorations. This is a bad demo. So you're like, how do I do this? Like, oh, that is the example request right there. Here's the sample response. Which is just handy because you just, APIs are so poorly documented, they don't have to be. So there's a bunch of extra, like, I don't know, there's like a lot of, basically anytime somebody says I'm super confused, I'm like, okay, here's what you do, and I add it to a public documentation. But then the other thing that a developer can do is there's a magic run in Postman button in this collection. Again, since it's public, you can actually import the whole thing into Postman and just run it just like I did, which is pretty fantastic. Again, this is like, I don't know if it's free actually. It's free for us because like they didn't have branding, they didn't have the URL stuff, and they didn't have CSS 10 seconds to load. So we were kind of the guinea pigs in a way, but it's pretty awesome. Like it's actually like measurably increased our enterprise sales, which is kind of crazy from having good documentation. And it keeps the questions asked to a minimum. Like, I don't know. I like the people coding against our stuff to like enjoy it and not bother me. So I can get both of those things with this. Yeah, I think that's but again, like we absolutely love Postman. There's some other tools like that, but this is our favorite. And yeah, go out and make an awesome API and test it. So I don't know. Is there any other questions on like API documentation?
I have one more. What's the format you're using to like document it? Is there a specific
Yep.
tool you're using?
So the Postman collection just takes Markdown.
Oh.
So yep, I completely missed over that though. So like I think this is like the header. So this is like the header information of all that. And then each call in the collection is its own section. Like the folders are a section, and then the call is within that a section. So like in the setup, I don't know if I have a description. Okay, so this is like the setup, and this is probably what most people don't realize that you have to run. It's its own folder, and it just kind of mirrors that. And then each request in your Postman collection is its own link. So you can like link to other stuff within it and stuff like that too. Good question. This is all marked down, which is awesome. And sometimes I'll do this for our internal stuff too, if we have like other stuff.
Should add that there's a t-shirt on the line for people who ask questions.
Yes, best question.
That's what Spencer was asking all the questions.
Yeah, if you're wondering why Spencer is asking so many questions. But yeah, any other questions about any of this stuff? Was it interesting or anything that you disagree with or suggestions? Questions? I don't know. It's fun to like I said, it's fun to make a public API. I would use this if I was making a private API in a bigger company or something like that. Like I know some people have done some stuff with just any API that's like, or again, even when I'm like trying to get another developer, like here's how I plugged into the Google Maps API. I have a folder that's just called Google Maps. It's got every request that I've ever used in it. because I don't know, I might eventually come back to it a year later and be like, oh, what header did I have to set, and like, how did I have to format this? Or some people just don't document it, and then you have to guess.
Do you know if there's an equivalent of this for the document leads?
So for like assembly APIs almost, or like databases and stuff?
Well, I guess they have the XML annotations.
Yeah, that's what I used before, was like you started a web API project and here's your like XML generator. And you put it like with triple slashes. I don't know that there's anything else like that for this. Like they are 100% focused on web APIs. Like Postman will never do that. So I don't know if there's somebody else that would.
We're just thinking it would be incredible if I was publishing like a NuGet package or something.
Yes.
And just have this.
Yes, like example code. They're just like, run it, start that. Do that. Let's do that.
You know, Nate said there's a lot of things that generate documentation, but a lot of the benefit here is that everything's integrated, so there's not extra work
Yeah.
for the sake of creating work, you know.
Because our documentation got out of date like the second we changed it. And this time it doesn't because like the requests all update just one place. Cool. Yeah, if there's no more questions, thank you all for braving the cold and please drive home safe. If you have any questions, you can email me, Nate@Travefy. You can find this lovely documentation. My email's probably on there. Or here. That goes.
Yeah, we visited.
So, maybe you have any follow-up questions later or want to talk like deeper dive on any of this, I can talk to you or get you in touch with the person that actually knows more about it. So, cool. Thank you.